Yes. All right, so I'm gonna send you guys the link. So here it is. So let's see, where is my chat? Right here. So here is the link. Ready, go. Okay, the link is on the in chat. So check it out. So this is where I will be uploading the live lectures, you know, that Tuesday, Thursday when you and I meet up. So I can't do it on Blackboard. It's a huge file. So yeah. So did you get that link, guys? So we did.
Professor, I got the link, but it says the playlist is not available.
Oh my goodness. Um, um, I will go ahead and fix it right after
Okay.
playlist doesn't exist. Oh my goodness.
Yeah,
Um,
I thought it was just my problem, so I wanted to make sure someone else had the same thing.
yeah, is that, does someone else have that same problem? For me, it says it's private. Oh, I see. Okay, I'll fix that right after class. How's that? But at
Yeah, you
least
have to make
we have
it
the
public
link.
for other
Yeah.
guys to
Yeah.
see.
I will. Well, I don't want to publicize it. I will make it unlisted, but you guys got the link. So if you have the link, you'll have access to it. I will fix that. If it says private, I will fix that right after class, guys. I promise. So, so that's where you find the videos. So now with that said, is there any other question or issues or problems? Okay, yeah, for me too. Okay, Juan and Tyrus. Okay, got it. I will fix that, I promise. So let's get to this particular problem. These are called mixture problems. It says a brine solution of salt flows at the constant rate of 6 liters per minute. This is like how fast, the brine solution is entering a tank. That initially the tank had 50 liters of brine solution in which it was dissolved in what, zero point 0.5 kilogram of salt. So initially the tank had what, 50 liters of brine and half a kilogram of salt in it to begin with. But then they decided to what, pour some more brine in it, and the speed of the flow was 6 liters per minute. The solution inside the tank is kept well stirred, so they kind of mixed it uniformly and flows out at the same rate, meaning it also flows out at the rate of 6 liters per minute. So that means the volume will remain constant. If you have different rate of the flow rate of outward flow, then the volume will be a function of time. But here, because what? The flow rate of a brine pouring into the tank is exactly the same speed as what? When it flows out, after, of course, it has been well stirred, then that means the volume is what? Kept constant. In other words, the volume of the solution in tank will be 50 liters regardless of the time. If the concentration of the salt of the brine entering the tank is 0.05 kilogram per liter, so these are concentration. In other words, this is like how much of this solution has salt in it. Determine the mass of the salt in the tank after t minutes. When will the concentration of the salt in the tank will reach 0.03 kilogram per liter? So as I mentioned, these are called what? Mixture problems. So this would be like right up chemical engineers alley. So these are called mixture problems. Okay, let me draw the scenario. This is what's happening. You have a tank. Okay, it has what? An outlet. Okay, and it has an inlet. Okay, like so. So they are pouring some what? Solution into the tank, but initially tank had what? 50 liters of brown and also had zero point 0.5 kilogram of what? Salt in it. So this red lines happens to be the brine. Okay, and these crosses is like the salt. Okay, these are like salt. Okay, so now what happens is they have a little device here which kind of steers as the brine enters the tank. It kind of steers uniformly the solution and then it flows out. So here is what's happening. To begin with, the initial volume was 50 liters. At time zero, we had 50 liters of brine in the tank to begin with, and the initial value of the salt was zero point 0.5 kilogram. In other words, I'm denoting V as the volume, okay, and A as the amount of salt. Salt. Then I'm gonna what? Say C1 is equal to 0.05 kilogram per liter. And I'm going to make sure we all know what C1 is, which is the same as what? Concentration. Concentration of what? Of salt, what? Going into tank. So this is like the concentration of the salt going into the tank or flowing into the tank or, you know, kind of in. So this sometimes they might call this like, sometimes they might call it C in, the concentration of in going, what, salt. Okay, so guess what? We're gonna show R1, which is the rate of flow of brine going in or flowing in. And I'm gonna show R2, rate of the flow of brine, what, going out. So, or I should say flowing out of the tank, yes? So, guess what? We do know initial value of the brine, which is 50 liters, and we know initial value of the salt, which is 0.5 kilogram. We also know C in concentration is what? Is 0.05 kilogram per liter. We also know R in is 6 liter per minute. Okay, these are all given. And we also know how fast the solution is pouring out, which is the same rate as it was pouring into the tank. So these guys are identical, correct? We like to find the amount of salt after 1 minute. Remember, we decided A stands for the amount, V stands for volume, C stands for concentration, R stands for rate. So you have two rates, how fast the what? Brine is going in, how fast is it coming out, and there is a mechanical device here which as you what put the brine in, it kind of steers, you know, mixes the brine with the salt in it. Question: what do you think the concentration of the salt going out is? Um, is this a fixed number as well? What do you think? Any guesses? The concentration of the salt going in is fixed. It's 0.05 kilogram per liter. Do you think the concentration coming out of the, you know, of the salt coming out of the tank is still constant? What do you think? Any idea? Is it constant or is it variable? Let me see what we got. The response is no, it's not constant. May I ask why?
It's because in the tank we have some salt constant inside already, and then mixed with the one get in, and then it's supposed to be um, different concentration after it get out.
At any given time. Excellent, excellent explanation. Did you hear what she said? She goes, because you're pouring what? Brine into and it gets mixed. I can't tell what the concentration of the what? The concentration of the solution coming out is not fixed. Why? It all depends at what time did you what? Stop the process and measure the concentration. So the concentration depends on how much brine did you pour in, so you can stop the process and measure the concentration. So even though the concentration going in was constant, but the concentration coming out of the what? Flow tank is not constant. So what is it equal to? Is a function of A over V, which is what? Amount of salt divided by what? Volume of brine, which in terms of the units, this would be kilogram per liter. So it's A over V, because I gotta know what the volume is, I gotta know what the amount is. So at that specific time, I can tell you what the concentration flowing out is. So therefore, this is going to be a variable. So it's not constant, as she said it correctly, and thank you so much. So here is what we do. We go, okay, what we have is what? dV dt is always equal to R in minus R out. That's the formula, yes? The volume is always what? R in minus R out. How is that possible? Check this out. If I write this as dV, R in minus R out times dt, notice the unit for R in was what? Was liter per minute. This is time, so that's minutes. These guys canceled, so you get liter. So therefore, the rate of change, so this is rate of change of brine at any given time is R in minus R out. Therefore, in our case is what? Is 6 minus 6, because remember R in and R out was identical. So therefore, this is 0. So that means if you take the what? Antiderivative of 0 with respect to t, you will end up with v of t is equal to constant. But what is that k equal to? It's exactly the same as what? The amount of brine which was in the tank to begin with initially. So this would be at any given time, not just time 0. Because the rate in and rate out is identical, so that's 0. So that just means the volume of the brine is constant, regardless of the time. So this would be at any time. So that would be something we gotta keep this in mind for upcoming what? Computations. As you can tell, we are not quite done yet. So now we gotta move on and see how exactly the rate of change of salt is equal to. Remember, this is the rate of change of salt, not brine. Well, turns out this is C in times R in minus C out times R out. And as far as the unit, it makes sense because C is what? Kilogram per liter. R is what? Liter per minute. But if you multiply both sides by dt, which is also minute, The minutes cancel, the liters cancel, you get kilogram. So unit-wise makes perfect sense. However, in our case, we have dA dt. What was the Rn? It was 6. What was the concentration going in? It was 0.05 minus R out, which is still 6, but the concentration coming out, we decided is variable. What is it always equal to? A over V. Okay, so this is AT over VT, but we decided V, the volume, is always constant and it's equal to 50 liters. So therefore, dA dt is equal to 6 times 0.05, correct? If you don't mind, let me just move the page. Minus 6, what? A of t, and that's 50. Ladies and gentlemen, we have a linear differential equation first order. In other words, I can rewrite this as what? dA dt plus what? Let's say this would be equal to, let's see, what is this? This is 0.03, is it? Is that right? Do I have that correctly? Is it 0.3, right? Is it 0.330? 0.3, and this would be what? 3 over 25a. Do you all see it? Just reduce this by 2. So that would be 0.3, right, guys? So therefore, this is dA dt, what? Plus 3 over 25a equals 0.3. There. This is exactly the same as dy dx plus p of xy equals q of x. Therefore, this is very much a first order linear non-homogeneous, because this is not zero, non-homogeneous ODE. And how do you solve linear equations? You find an integrating factor. Integrating what factor? Is that right? What is integrating factor equal to? E to the power of, in this case, is what? P of t dt. Okay, so what is my P of t? Is this function including the what? The sign. So it's positive 3 over 25. Therefore, my integrating factor is e to the power of antiderivative of 3 over 25 dt. So what is this? This is the same as e to the power of 325t plus c. But because I need one integrating factor, I'm going to let that c to be equal to 0. What is the bottom line? The bottom line is integrating factor is e to the power of 3 over 25t. Okay, so now I'm going to go back to this equation number 1, and I'm going to multiply both sides by integrating factor like so. E to the power of 25t times dA dt plus e to the power of 3 over 25t times a 0.3 e to the power of 3 over 25t. Remember, we said last time, the minute you multiply both sides by integrating factor, the left side is always, rain or shine, automatically the derivative of what? Product of the unknown function and your integrating factor, which in this case, the integrating factor is what? E to the power of 3 over 25t. Can you tell what my unknown function is, guys? Anyone? What am I trying to solve this equation for? Which variable I'm trying to solve this equation for? Yes, so this is times a. So very good, thank you guys. So the minute you multiply, standard what? Linear equation. What does it mean to say equation is a standard? The coefficient of your derivative must be +1. If there is anything attached to dA dt, you gotta divide it through then find your P of t. Okay, otherwise you would that would lead you with the wrong answer. Once you multiply both sides by what? Integrating factor, the left side, rain or shine, it's always the derivative of the product of your integrating factor and your unknown function, always. This is not happy coincidence. It happens all the time. Let me see what I have. Oh, A, that's right. Thank you, guys. You're right. It's A. So this guy is 0.3 e to the power of 23 over 25 t. Multiply both sides by what? By dt, so you can change the problem into what? Differential form, because right now I can't attach the integral sign to both sides yet. You know, separate the variable, put the dt where what? This guy is. So this is called differential, this is called derivative. We need differential form to what? Take the integral. In other words, if I have dy dx is equal to f of x, I have to go dy is equal to f of x dx, then I can take the integral, correct? I can't take the integral of derivative form. I have to change it to differential form. Anyways, you take the integral of both sides. The left side is easy because what's inside the bracket simply pops right out. Okay, now I have to, honest to goodness, take the derivative of the what? Right side, correct? What is the derivative of the right side? 0.3 goes for the right. What, I'm sorry, antiderivative. The antiderivative of e to the power of 3 over 25t is what? 25 over 3 e to the power of 3 over 25 t. Don't forget the c. Correct? Now do me a big favor and divide both sides by e to the power of 25t. So divide both sides of this equation because you're trying to solve the equation for a of t. So this is all a of t. So this is a of t, okay? So you're trying to find the amount of salt at any given time. Divide both sides of this equation by what? By e to the power of 3 over 25t. When you do, what do you get? You get a of t, remember this is a function of time, it's not fixed, equals what? What would that be equal to? What? 0.3 times 25 over 3 plus c divided by e to the power of 3 over 25t, correct? Do I have an initial value for amount of salt in the tank? I sure do. Remember, a sub 0 was given to me as, what was it? 0.5 kilogram. Impose this condition so you can find C. So go like 0.5 equals, let me just make sure I'm okay here. If you replace the T with 0, you would end up with what? 0.325 over 3 plus C over 1. Why? Because e to the 0 is equal to 1, remember? So solve for C. Believe it or not, C comes up to -2. So therefore, the amount of salt at any given time in the tank is equal to 2.5, that's this guy, minus 2 times or over e to the power of 3 over 25t, which you can write it as 2.5 minus 2 e to the power of -3 over 25t. There you go, and this is so many kilograms. There it is. So I got the amount of salt at any given time. It's governed by this equation. Okay, so that's part A. What was part B? Does anyone see how to do part B. When will the concentration of salt in tank reaches what? 0.03 kilogram per liter. When means what time will the concentration will reach this particular amount? Does anyone have any idea how this might work? So what should I do? Yes.
You set the amount divided by the constant volume. So you get
Correct,
the
correct,
concentration, and then
correct.
equal it to the amount you're trying
Concentration
to
is A over V, correct? You know the concentration, okay, what was it? 0.03. You don't know what amount is, but you do know the volume, which is fixed 50 liters. So therefore, this tells you when the concentration is 0.03 kilogram per liter, the amount is 1.5 kilogram. Just multiply these two numbers together. So for this amount, the question is find the time. So what do? I go back to the equation, replace the A with 1.5 kilogram, and then 2.5 minus 2 e to the power of 3 over 25t. So my job is now to solve for t, which is the amount of time. Do you see it? How do I solve this, you ask? Well, I kind of what? Subtract 2.5 from each side. Okay. And what would that give me? Is that like -1, -2? Is that right? And that's e to the power of -3 over 25t. So this kind of gives me e to the power of -23 over 25t is equal to 1/2. Because the variable I'm trying to solve is sitting at the power, so I have to take some sort of log, preferably natural log. Okay, that's where the log comes handy to solve exponential functions. So now the beauty of it, now you can what, liberate this power and write it next to the natural log. Okay, there. But natural log of e, you and I, we both know, is equal to 1, and natural log of 1 is 0. That's just for future reference. So this guy is 1, so -3 over 25t is equal to natural log of 1/2. Therefore, t is equal to natural log of 1/2 divided by 3 over 25. Now you use your good old scientific calculator or graphing, and you will end up with 5.8 what? Minutes. At this time, concentration would be what? 0.0, what was it? 3 kilogram per liter. That's why the concentration flowing out is not constant. It solely depends on the time, because it all depends how much what? Brine you pour into the what? Into the tank. Now let me ask you a follow-up question and see if you really super got the idea. You see here we were what? Pouring brine into the tank, this problem. What if I change the brine to what? Pure water. Okay, pure water, 100% water. What do you think will change? Anyone?
concentration decreases over time.
Concentration of water is 0. Water has no concentration, it's pure. There is no other chemicals added to the water. Supposedly water is, pure. So that means concentration in, that means C in would be 0 if you pour pure water into the what? Tank. That would be the difference. So that what happens is right over here, this guy goes to 0. This guy goes to 0. All you have to do is what? You won't have this anymore. You just have to solve this equation, and that equation is separable. There is no need for what? For integrating factor. You just separate the variables. So if you pour water into the tank, the solution becomes, easier because C in becomes 0, so you lose this term. And all you have is what? dA dt is equal to negative 3 over 25a. This is separable. Just put the a on one side and dt on the other side, and you'll be on your way to solve for a. Do you see it? So that was just my little 2 cents of advice, just in case they pour pure water. That means water has no concentration. Do you all see it? So how we doing so far, guys? Any questions? I did circuit problem last time, I think. Please correct me if I'm not, if I'm mistaken. And I also did the Newton's law of cooling. Did I do those problems that you remember? Yes, you did. Thank you. So that means we are done with word problems. So there are 3 kind of word problems. Also, I did way back a couple of weeks ago free fall problem. Remember, the guy was 5 feet tall and he threw an object, a tennis ball, up in the air, and we found out the speed at impact and maximum height and all that good stuff. So it would be nice if you kind of know how to set up, depending on your major. That would be really super nice to learn these, so it would help you in your classes. One of the problems which we did was RL. So this is for our EE majors. I like to just take a few minutes and do RC problem. Notice once again, the voltage source is what? Fixed. So that means this is a battery of 100 volts. Otherwise, if the voltage was like sinusoidal, they will have this notation. So you would have like 100 sine of t plus something else. But if they have like constant, so that means it's DC volt, not AC. Okay, so you still have resistor, which in this case, this is the notation for ohms. So it's 5 ohms. Okay, but then you have a capacitor. Last time we had inductor. So here's the notation for capacitor, and the capacitor 1 over 50, and the unit is farad. So this is like farad. Okay, so the question is, what would be the amount of what? Current flowing into the circuit, correct? But it says the capacitor is uncharged initially. The capacitor is uncharged initially. So if you remember the what? The voltage across a capacitor is 1 over CQ. Q is what? Electric charge. Electric charge, correct? And the way it's related to the current is I is dq dt. Okay, so in other words, and the unit for I is amperes, amps. In other words, the rate of change of what? Electric charge with respect to time is called current. And the unit for current is what? Amp. And the unit for Q is coulombs, right? So remember, we use Kirchhoff's law. We go, okay, 5I, that's the voltage across this using the Ohm's law. Voltage across this is 1 over 50 times Q, and that these guys have to offset this 100 volts. So the sum of the voltages on each of the elements should add up to the amount of what? Voltage source, yeah? So this would be like 5IT plus what? 50Q is equal to 100. But keep in mind, I is equal to what? dQ dt. So ta-da, we have a what? linear differential equation. Do you all see it? So, so what? So divide both sides by 5. So to put the equation in standard form, so this would be like plus 10 cubed is equal to, what was it? 20. So now you can what? Find the integrating factor, which is e to the power of positive 10 dt, which is e to the power of 10t. Because this guy is constant, you can also pretend this is what? Separable. How? Check this out. You can go dq dt is equal to what? 20 minus 10q. Okay, so go like dq over 20 minus 10q is equal to dt, integrate. So that way you don't need integration factor. But remember, that only happens if when you have a constant on the right side, correct? So you can just integrate and you'll be on your merry way. But if you decide to stick with the procedure, then because this is a linear differential equation, so I need integrating factor. When you multiply both sides of equation number 1 by this integrating factor, the left side is always derivative of integrating factor times the unknown function. The unknown function is the electric charge, not the current yet. Because remember, it's dq dt, that means you're solving for q. And the right side pretty much stays as is. You all see it. So now if you multiply both sides by what? By, what was it? dt, okay? To put the derivative in differential form, you're ready to what? Take the integral. When you do, the left side is easy because it's what you see inside the bracket is what you get. Okay, this is supposed to be t. And on the right side, you get what? 1 over t e to the 10t, don't forget the c. Is that right? So now, how do I find c? Any idea how to find c? What is my initial condition? Yeah. Initial condition is the capacitor is uncharged. That means there is no electric charge in the capacitor. So that means Q of 0 is 0. There is no electricity. Okay, capacitor is uncharged. So there is no charge. Therefore, this would be like what? 0, 1 times 0 equals 1 over 10 plus C. Is that right? So what would C be equal to now? Do I know that? Okay. So what is it equal to? So C will be equal to negative 1 over 10, is it? Is that, am I doing this right? So make sure I didn't make any mistake in computation, please. So this would be e to the 10t times q of t equals 1 over 10 e to the 10t minus 1 over 10. Is that right? Did I do that right, guys? This is 0, this is 1, that's 1 over t. I guess we are okay, right? So therefore, what? Q of t, if you divide both sides by e to the 10t, would be 1 over 10 minus 1 over 10 e to the negative 10t. Well, wait a minute. We were supposed to find what? The amount of current right here. So this ain't it. So what do you think the answer might be, guys? That's not quite it. Any idea? How do we go from electric charge to current, guys? Yes. Anyone? Remember, the idea was find what I of t, the amount of current which flows into the circuit. So we are not quite off the hook yet. Any idea, guys? Anyone? Yeah, nothing? So to find I have to take the derivative of this guy, remember? When you take the derivative, you get this guy. Okay, so this is pretty much so many amps. I hope we did this okay. Did we do this okay? That's 5, the 50, 100, divide by 5, that's 10, that's 20. Then I got e to the 10, then I multiply. Do you see what happened? I was like, something went wrong. Do you see what happened? Somewhere along the line, I dropped the 20. Yep, I apologize. So 20 goes for the right. I knew it, I knew it. So this would be like what? 20. So this would be 20 over 10. So this would be what? What is this? Remember, this guy is 20 over 10, which is 2. So what would this guy be? 0. This would be 2. So C would be -2. Sorry about that, guys. It looks suspicious. Yeah, this didn't look like the correct answer. My apology, guys. So this would be e to the 10t, q of t, what? This would be 2 because it's 20 over 2, and then c, and then plus c. No, but c is c came up to -2. Very good. Wow, what a mess. Sorry about that, guys. So this guy is what? 2. This is also 2. So once again, please accept my apology. This would be 2 minus 2 e to the negative t10 coulombs. So I is what? Sorry about that. It's dq dt. So it will be 0. That will be plus 20 e to the negative 10 amps. There you go. Sorry about that, guys. It's getting late afternoon. I apologize. So do you see it? So this would be, is it -1? How so? Let me see. Remember right here, when you integrate it, let me back up a little. So remember right here, we decided this is what? 10t q of t equals, remember I dropped the 20. You know, when you divide both sides by 5 here, don't you get 20 here? I dropped it. So that's why the answer didn't come up right. So check this out. So if I, what? Multiply both sides by dt, correct? And integrate, left side is e to the 10t q of t equals, here the answer is 20 over 10 e to the 10t plus c. But remember, q of 0 is 0. Let me just show you what I'm writing here. Sorry about that. So what does that mean? This guy is e to the 0, which is 1. That's 0. This guy is 2. That guy is 1. That guy is c. This is 0. This is 2. Isn't c is equal to -2? Remember, that's 1 times 0. So it's 0. Move the 2 over, so it's -2. I think that's what it is. But don't forget, once you find Q, that's coulombs, that's electric charge, but current is how fast the electric charge changing with respect to time, which is this much. So there you have it. Sorry about that, guys. All right. So let me just for about 10 minutes or 15 minutes talk about this section 4.2, at least get you guys going so we can continue this next time. It's about homogeneous linear equations, okay, specifically second order. And one more idea with constant coefficients. Constant coefficients. In other words, the equations in this particular section, they're going to look like this. Okay, like this. There you go. Do you see it? Notice A, B, C are constant. So what is the title of this equation? Second order, because I have second derivative, that's the highest derivative. Linear, because, you know, none of these guys have any powers. None of these guys have this, they appeared at the bottom of a fraction or exponent or at the exponent of a function, or they are not part of, you know, angle for any trig function. So this is honest to goodness linear. And the constant, the coefficients attached to these functions, derivatives and the function are constant. And it's homogeneous because you got a zero on the right side. Quick example of it. Let's say I got 2y prime minus y prime, y double minus y prime plus 6y is equal to 0. That's what we are talking about. Okay? But remember, sometimes some of these guys might be missing, except this guy. Sometimes I may have this guy plus y, and these are, of course, functions of x. But this is still second order, homogeneous, okay, linear equation, even though this guy is missing, but that doesn't mean this is no longer linear. It's still linear, and the coefficients of these functions and this function and the derivative is, as you can tell, constant. So question is, how do you find the solution of these kind of differential equations? To begin with, I'd like to go over a concept which we will see this over and over in what? In linear algebra part of the course. It's called linear combination. The definition is, given two functions like f of x and g of x, there exists, that means we can find c1 and c2, these are constants, okay, such that what? I can form this summation. So if you can find constants such that you can express the functions as summation of scalar, different scalar of these two functions, the result is called linear combination of f of x and g of x. That's how we read this. Case in point, suppose I have two functions, let's say e to the 3x and e to the 2x, or negative 2x. How would you write the linear combination of these guys? So the linear combination of what? Of e to the 3x and e to the negative 2x can be expressed as c1 e to the 3x plus c2 e to the negative 2x. What if you got more than two functions? What if you got x squared, x, and let's say e to the x? How would you write the linear combination of three functions? Then you should say there exists c1, c2, c3 such that you can rewrite these functions as c1x squared, c2x, c3 e to the x. What you see inside the box is called linear combination of these three functions. Provided such c's exist, provided you can find these C's later. So that's what the topic of linear, or the title, or the meaning of this vocabulary is. So to say linear combination of what functions, that's what you mean. This idea also what applies to vectors. So if you have vectors in 3 dimension, then you can take their linear combination. If you remember, those of you had multivariable function calculus, remember one way to show the vector was this. The other way was write this as a linear combination of what? 3 unit what vectors called ijk. So we call this linear combination of ij and k. In this case, your C1 is 2, C2 is 3, and C3 is 4. Do you see it? So that was called linear combination, but they never mentioned that in that course. Okay. When do we say two functions are linearly independent? So linearly independent functions, namely two functions. Okay. The procedure I'm just about to outline only works for two functions. If you have three functions, this doesn't work. So before I move on, note this method, okay, does not apply for three or what more functions. It only applies for two functions. So here is the definition of linearly independent. Two functions are said to be linearly independent. If you divide one by the other one, you don't get constant. So k is constant, you don't get constant. In other words, the result should be a variable, not a constant. If that's the case, then we say, what do we say? We say f of x and g of x are linearly independent. Linearly independent. In layman's term, it means you cannot combine these guys. They are not combinable. Case in point, let's say you got, oh, I don't know, sine of x or f of x and cosine of x for g of x. Question, are what? Sine of x and g of x linearly independent? Are they linearly independent? Well, the procedure is take the what? Quotient of these two functions and see if you get a constant. If you get a constant, they are linearly dependent. If you don't get a constant, they are linearly independent. What does that mean? That means you can combine them. In other words, right here, I get what? Tan of x, which is not constant. So the idea is, look, sine of x and cosine of x are very much linearly independent. On the other hand, if I have two functions like, let's say, 6x squared and let's say 12x squared, these guys are linearly dependent. Why? Because if I take one of them and divide by the other one, I get constant. So therefore, we call these guys linearly dependent functions. What does that mean? That means I can combine them here. Isn't that like 18x squared? Notice I combine them. But there is no way you can combine what? Sine to cosine. You still have to express them separately. They are not combinable because they are not like terms. Same thing goes for e to the 3x and e to the 2x. These guys are linearly independent as well. Why? Because if you take the ratio, you don't get a constant. What do you get? You subtract the powers, you get e to the x, which is not constant. So therefore, these guys also fall into the category of what? Linear independency. So what's the big deal about linear independency? Well, let's go back to the solution of these guys. The solution of these guys, usually you would end up with two functions, y1 and y2, which later I'll define what they mean by fundamental solutions. But right now, let's just kind of finish this idea, and we'll talk about this later. These functions, in order to be solution for what? For this differential equation, they have to be linearly independent. Why? Because the final answer will be linear combination of these guys, okay? And if they were linearly dependent, so that means they were combinable, and in turns, that means I would only get one C. And remember last time we talked about the order of differential equation determines the number of C's you gotta have in your final answer. So they better be not combinable, so you can have what? Two C's. Otherwise, if they were combinable, which is dependent, then you could what? Combine the C's, then you would come up with one C that violates the rule. Because the rule says whatever the order of differential equation is, you gotta have that many C in your final answer. Do you see it? The next idea, let me just do this. So the solution to this kind of equation, a y double prime, py prime, cy is equal to 0, is always, rain or shine, in the form of what? Form of y is equal to e to the power of some real number times x. So this would be the form of the solution for this kind of differential equation where r is any real number. Okay. So how do you do this? If that's the solution, e to the rx, so I can take two derivatives of this, like so. Okay, sorry, I'm writing fast because I'm running out of time here. So let's call this equation 1, call this equation 2, call this equation 1. Substitute 2 into 1. So replace what? Y double prime with r squared e to the rx, and y prime with r e to the rx, and y with e to the rx, set it equal to 0. So what do you get? They all have e to the rx in common, so factor that out. So you get ar squared br plus c is equal to 0. So you have product of two functions, namely this polynomial and this exponential function multiplies to 0. So that means either of these guys had to be 0 to begin with. Is that right? But this guy's exponential function, it cannot be 0. I don't care what x is or what r is. For any value of x, for any value of x, this guy never is equal to 0. It's exponential function, right? So the only hope is this. And this guy, ar squared plus br plus c, has a name. It's called auxiliary polynomial. Auxiliary polynomial. What is so good about auxiliary polynomial? The roots, that means if you set this equal to 0, solve for r, okay, you get two answers, let's say r1 and r2. Therefore, your solutions would be e to the r1x, e to the r2x. Because remember, the solution is supposed to be in this form. Because this is a quadratic equation, it always gives you two answers. But in this case, tonight, I'm just going to focus on what? Two distinct, that means different, real solutions. Next time, we will see what happens if these guys are repeated solutions. And then what if the answer comes up complex? What if the solution is imaginary? So how would that affect the solution? So the bottom line is the general solution, so this is called general solution to these kind of differential equation, once you find the values of R, is a linear combination of these guys, provided these guys are linearly independent, and therefore the final answer is C1 e to the R1x, C2 R2x. This is how the solution for a second order linear homogeneous equations with constant coefficients should look like. This is your final answer. Okay, so with that, let me do a very quick example so you guys, at least you can see one example how this is done. Is there any question about anything on this page?
Can you scroll down to the bottom part, the final equation, the general solution?
Notice you gotta have two C's and they are not combinable. Why they are not combinable? Because these guys are linearly independent. They have to be, otherwise you cannot claim them as being your solution. So one of the criteria for solution is as follows. Let me tell you quickly, just orally without writing, because I will repeat this next time. You can't just take any random function and form a linear combination, say I'm done. No, you gotta check and see first, these guys are linearly independent. Each of these guys satisfy the original function, and the number of functions you get here should match the order of differential equation, meaning if the order was 3, then I would have 3 functions. Because the order was 2 here in this section, so I have 2 functions. So the number of functions in your this is called fundamental set of solution, and I will explain that next time, what they mean by fundamental solution. The number of solutions depends on the order. So does the number of C's. Are we good? Can I do one example quick so we can go home? Here it is. Very simple equation. Solve y double prime minus y prime minus 6y equals 0. Okay. Remember what? This is your A, this is your B, and this is your C, isn't it? How does the polynomial, auxiliary polynomial look like? AR squared plus BR plus C. So in our case, how does the polynomial, auxiliary polynomial look like? R squared minus R minus 6. Set this equal to 0, solve for R. Okay, this is called auxiliary polynomial. But in my case, A is 1, B is -1, the coefficient of y prime, C is the coefficient of y. Okay, so I can factor this, good old algebra, 3, 2, negative plus, there you go. So therefore, either this guy is equal to 0 or this guy is equal to 0. So that means either R is equal to 3 or -2. Correct? But remember, the solutions should look like this, always, rain or shine. Notice I said always. If you have a linear equation, homogeneous linear equation, regardless of the order, next Tuesday, I'll raise this to the third order, third derivative. Still, the solution looks like this. So as long as you have linear equation homogeneous with constant coefficient, this is how the solutions should look like. So in our case, the solutions are e to the power of 3x and e to the power of -2x. But that's not it. This is not the answer. So not the final answer. Okay, we are not off the hook. The final answer is y equals linear combination of these guys, which is C1 e to the 3x plus C2 e to the -2x, ladies and gentlemen, this is my final answer. So because I have two C's, so you have to give me two initial conditions so I can find what C1 is. Otherwise, for now, this is called general solution. The minute you give me initial conditions, I find C1 and C2, that would be called particular solution. And I shall continue this next time and show you what happens if the roots comes up repeated or complex. In other words, what if I set this equal to 0 and the answer came up to 2 plus or minus 3i? What do I do now? What if I set this equal to 0, the answer came up to 4 twice? What do I do now? In other words, what do I do if the roots are repeated or complex? So we will discuss that but next time. Thank you so much, guys, for participating. I sure appreciate it. Have a great weekend. Stay safe. I will see you next time. I'll stick around if you have any question. Have a good night, guys.